In the previous part of the lecture, we spoke about from the supplier's point of view, how you're supposed to understand the architecture for the design of the state design pattern and also the template design pattern. Specifically, we talk about for implementation, how the template design pattern is actually implemented and also executed at the runtime, exploiting the dynamic binding, which we also learned about previously. So that's something I will rely on you to really understand. Otherwise, you can get in touch with me just about how to understand them properly. Okay, so now we're going to talk about from the other angle for the design pattern, which is how can we use the pattern if we are the clients. So that's something we'd like to talk about. So let's go back to the slides. At the runtime, from the client's point of view, you can think about you're going to have some application objects, and then for every client's code, you're going to have the transition table, which we already spoke about, which is going to encode the transition table for the formulated model for the finite state machine for your interactive system. And also, we're going to declare a polymorphic collection over here. You can see it's an array of states. And remember, the state is the top level of the hierarchy for the state pattern. So under the states, you can have dynamically initial, fly inquiry, seek inquiry, reservation, confirmation, and final. So now notice one thing here. It's not really singleton design pattern, not the case. However, we only need one instance for each state over here. You can see that will be sufficient. So you don't really have to create more than one initial states. Also, you don't need to create more than one flight inquiry states and etc. It's not really singleton, but it acts almost like a single instance for every state. Alright, so let's now see in detail at the runtime how the client is going to build such polymorphic array of states. So we consider the application class with a constructor make. And first of all, we have the transition table, and notice that we're going to encode every state and also transition using integer. So that's just simple. On the other hand, we're going to have a polymorphic array of states, and the static type for every member in the array will simply choose the top of the inheritance hierarchy, which is the states. An analogy for this example here would be, previously when we talk about polymorphic collection, we say an array of students or a linked list of students, and dynamically can be either resident students or non-resident students. So analogously, over here at the runtime, what can be each member dynamically? Well, for the array, in that case, it can be either of the 6 effective descendant classes under the state hierarchy, right? So that's something you will see. We'll revisit the example in a moment. Okay, so now we have some attribute over here. Initial over here simply tells you which index would be which index in the array should be referring to the initial states. I will show you very soon as to why the initial should not be of type states. It should just be of type integer. You will see the use of it. Okay, and then we'll see the number of states over here. So the number of states tells you how large the state space is. So in our particular case, in this lecture here, so the number of states would just be 6. And also the number of choices, number of transitions possible, it will be also 3 in this particular example. And then we're gonna construct the application. In that case, we're going to take from the external user. So what should be the dimension of the state space, right? How many states and how many possible transitions from each state. We're gonna initialize them, and then we're going to initialize a 2-dimensional array. Okay, you can also look up in IFO, it's called array 2. Okay, if you want to look it up. And the way to use 2-dimensional array would be very similar to how you do it in other programming language. And then we simply create a states array to just be empty. We're gonna grow it later. And what could be the class invariant over here? So let me ask you this. If I want you to write an invariant about the size of the transition table, the dimension, it's a 2-dimensional array. So what should be the relationship between the dimensions of the transition table and the number of states and also number of choices? Pause the video before I show you the answer. Okay, assuming that you have thought about it, basically the number of rows for the transition table should really corresponding to the number of states. And also the number of columns for the transition table should be corresponding to the number of choices, right? So hopefully you can easily imagine that. Okay, that's exactly what we should write for the invariants. You can see. So always remember to think about under what circumstances should the application object to be considered as valid. In this case, we are saying that it will only be valid if these two attributes are corresponding to consistently the dimension for your transition table. Okay, that's something you want to also practice yourself. Okay, let's continue with the same application class. We still got these two attributes. Let's see other routines. So we got put states. So this is the feature similar to the add students in the previous inheritance lecture. Remember the consequence of having polymorphic feature arguments is that you have a polymorphic collection. Previously, we simply say add students, and then S is of type students. The consequence of that is that dynamically the students array can just be either resident students or non-resident students. So now by making this particular command, you can see the polymorphic arguments over here is simply of type states statically. So that means dynamically it can be any of the descendant classes of the state class. We'll see that. Okay, and then the way for you to really put into the states array will just be using the force. You simply insert into the end. We'll visualize that in a moment, right? I just want to go through with you all the features. Okay, I can choose the initial. Basically, out of the 6 different possible states for our particular application, which one should be the initial state? We'll simply set the index, okay? Okay, and then, so this one you can see the initial over here is a previous set, previously mentioned that. So it's actually an integer rather than a states. Well, you'll see exactly why. And also we got put transition over here. So now, just for our convention here, we simply say the parameter goes like, you want to say what would be the target states given that the current state is source, and also the transition we're trying to make is choice. Okay, I will give you one example in just a moment. Okay, in that case, we'll simply put into the transition table. You can see the target over here, and the source over here, and also the choice and the choice over here. Let me just illustrate to you a few points at which I just mentioned. So number one, how do you put the transition? So let me illustrate this one over here. Put transition over here. So how do you do that? So let's just take one example over here. Let's say, how do I put this particular how do I put this particular transition? Okay, how do I do that? Basically, think about for this one here. I'll just annotate exactly what they are. So think about this state over here is the source, and this state over here is the targets, and this 3 over here is the choice. So that means in order to really put this transition into the transition table, you will have to say put transition. Okay, so now you have to put a target first, which will be 5. Right, you can see the 5 over here, and then the source, which will be 4, and also what would be the action you have to take, the choice. In that case, it will be 3. So that's how you put a single transition into the 2-dimensional matrix for our transition table. Okay, that's point number 1 I would like to make. And point number 2, I want to emphasize again. So this particular routine is what makes the polymorphic array of states possible at a runtime. Okay, so let me first of all write down. Okay, here the consequence of having a polymorphic arguments, more specifically, this is a polymorphic argument I'm talking about, is we have a polymorphic collection of states. So this is something you will see even more clearly later on when I illustrate how exactly to call these features together, right? So polymorphic and also polymorphic. Okay, so now I want to talk even more in detail about this particular argument over here. Remember, the way to understand about polymorphic argument is you want to think about the call by value. So we talk about call by value. So think about every time when you are trying to call put states over here, if you put, for example, some variable O, some objects O, and then whatever index, okay? The index here is not really important. So now, when you're calling this particular one, implicitly you know that what you're really doing is, you are doing that as the first line of the implementation implicitly. You're saying that the parameter S is assigned to the argument value O over here, right? And now, what O points to dynamically is going to be the new dynamic type for the parameter S. So that is why when you're creating this particular array, every member is going to be referring to whatever the dynamic type is for each input value you put using the put states. Okay, that's basically something you have to recall from our previous lecture. But we're going to see again exactly how this is going to happen. But for now, I just want to recap very quickly for you. Okay, so these are the 2 points I would like to mention about from the client side. So that's just one class. And then the next one would be I want to do one example test to really show you how you can set up the client's code, given that we know already how the various feature in the application class. So this will be exactly the lines I would like to illustrate. So now I would like to just switch to iPad and then illustrate line by line together with you. Okay. So for this particular test, now in our context, we know this is the state transition diagram for our application. And this is the eventual runtime structure we would like to build. But I'm going to show you bits by bits how it is built. Okay. Let's now, first of all, try to start with the application. We'll see the app over here is simply of type application. And the current states over here is simply states. And notice that this is polymorphic, meaning that whatever that's really assigned to current states, as long as it's a descending class of the states class, which means any of the effective descending classes, it will be okay. So it's polymorphic. And also the index is integer, which I will illustrate to you how it is used. Okay, let's make it a little bit bigger over here. Okay, that should be good. So now, first of all, we simply say creates application.make, and then we say 6 by 3. So this will be the number of states. And here will be the number of choices that's actually available for to be used as a transition. So accordingly, what we're going to do is app is now pointing to the application class over here, and then its transition over here is simply just going to point to a 6 by 3 table. You can see 1, 2, 3, 4, 5, 6 by 1, 2, and 3. 6 by 3 transition table, right? That's exactly what this will do. And then you can think about initially the arrays is simply just empty, just initially, right? But I'm going to grow it gradually. Let's see exactly how we do it. So now the second line over here, when we say app.put states, remember the put states? The put state is really where the polymorphic arguments actually occurs. In that case, we'll simply force whatever the state we are passing into whatever index we're passing. We're just going to put into index 1, 2, 3, 4, 5, 6, right? One by one. Let's say for this one here, we're saying that we're going to put into index 1. So index 1 is over here. What should we put into index 1? We want to create a new object over here, initial. Okay, so now we want to think about whether this particular passing is actually valid. Is it valid? Well, very easy to judge, right? Based on our previous understanding for the polymorphic assignments, you can see for the put states over here, the S is really of type states. So now what you want to ask yourself is the initial over here a descendant of the parameter states? It is, right? It's just one of the descending classes, so this will be valid, okay? This will be valid, okay? So now what we're doing is, so for index number 1, so now it is going to point to dynamically an object of type initial, right? So that's how we do the first one. And then we say similarly for other 5 states. So now we're just going to say for index number 2, we're simply just going to create another object of different dynamic type, flight inquiry, and etc. So eventually you can see for every member over here, let me emphasize again. So you can see for states here 1, 2, 3, all the way to, let me make a little bit more room for myself. all the way to 6, right? Every member over here. What's their static type? Their static type is simply as declared, simply just of type states. But what about dynamic type? For dynamic type, it's going to be different for each one of them. For example, for states at index 1, the dynamic type is initial. For states at index 2, the dynamic type is flight inquiry. For at index 3, the dynamic type will be seat inquiry, and etc. Right? That's why it's completely polymorphic. All right, so now we're just going to go to the next line. The next line here is kind of straightforward. We'll simply say we want to choose the initial state to be index 1. So what this will do is it is simply just going to set is this one here. Okay, this one is going to set the initial, which is an attributes, to just 1. Okay, we'll see exactly how this is going to be used in just a moment. Okay, but all you need to know is this one here, this line here, simply set the app.initial to be 1, and then followed by. So let's say we want to put the transition one by one. Well, we already illustrated example already. Let's just see one more. So what this one is saying is, if we are currently in state number 1, and we are taking action number 1 over here, and then we're going to state number 6. So that's exactly what we're doing here, right? So what does this correspond to? What that will do is it's going to say we are now in state number 1, and then we're putting action number 1, and then the corresponding value should be filled in as 6. So that's exactly what this line is trying to do. And then we have to, similarly, we got to do the similar setup for all the other 10 transitions. You can see we also got, what we just finished was only this particular transition, but we also got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 transitions you have to fill in. Okay, I'll let you do as an exercise. Okay, so let's now, we're halfway through. Let's just go on. And then we got this particular local variable index. Think about index is like a cursor. So we want to know where we are for the current states. So now index will be, initially simply will just be app.initial. Remember I said before, when we say choose initial, it has set this particular value to be 1, meaning that the very beginning value for index would just be 1. Okay, so now let's see the fun part. Let me just highlight this one here. You can see the current states is exactly over here, right? So now when we say current states is assigned to app.states at index. Okay, so now this is something we want to be careful here. So now think about the current states. Let me put the current state here. The current states statically is simply just a state, right? Statically. The static type is simply just the states. And now, when we say current states is simply assigned to app.states at index 1. At index, as we initially set, is simply just 1. Index 1 is really referring to this particular index. So now, the current state is really pointing to just this particular object over here. Let me just highlight it here. So current state right now is pointing to this particular one. So that means the static type for current state remains to be states, but its dynamic type has been changed to initial over here. Okay, so hopefully you can see that. And now you can do some instance of check. You can simply check to see attached initial current states, right? We talked about the cast syntax previously in the review. So now if you try to check to see the current state dynamically is really referring to some initial objects, it will be simply just true. Okay, I'm going to leave you with that. Let's go on with the next one. So now we can try to do some transition. Let's say the transition we want to do is, let's say the current state is simply just initial. So you can think about current state is really the initial states. Let's say from this particular states, we want to make a transition by choosing 3. So what we are really trying to do is this. So now we are trying to say this. Let's say we are currently in state number 1, right? That's the current state is really referring to 1. And we want to make a transition by choosing 3. When we choose 3 over here, so that means we are going to go to state number 2. So you can think about state number 2 is going to correspond to the new index. let's see how that's going to happen. So we are simply just going to over here, when we call the transition function app.transition, so we're referring to this particular table, and then index and 3. So index currently is simply just 1, so that's corresponding to the current state. So we're going to 1 over here, okay, 1, and then we are choosing action number 3. So now when we choose 3, so that one is going to give us 2. So that means the 2 will now be the new index over here, so 2. So that means we are really transitioning to state number 2. And then we're going to update the current states. So let me just use a different color here. So now the current state over here is now going to be assigned to the state objects that is stored at index 2, right? This is 2 over here. That's why it is 2 over here. So 2 is really pointing to this particular state object here. So now the current state, rather than pointing to this object over here, so the current state is now going to point to this particular state over here, right? State at index 2. Okay, let me just emphasize that by highlighting it so you will see. So you can see this one here is really pointing to the state object at index 2. So after this, you can see after this, the current state, it will be flight inquiry dynamically, right? So that's why if you try to check the attached syntax, it will be referring to flight inquiry dynamically. So this is a very simple manipulation of what's happening over here. So let me recap very quickly for you before I summarize everything. Basically, you have to create in order for your clients to set up, they have to do the following. Number one, they have to initialize the app object by specifying the dimension for the transition table, and then they have to set up all the polymorphic array of states depending on how many states you have. In that, we're going to set up each one one by one. So the polymorphic array we have is exactly set up by this fragment of code over here, and then we're going to choose the initial states index, and then we have to set up the transition table over here. That's also straightforward. So now what you really want to understand is we're going to keep updating the current states over here as many times as necessary. So now initially current state is simply assigned to the index 1 of the polymorphic array, which is exactly over here, right? That's what we did. And then once we have done some transition over here from the current states, given some option, given some choice, in that case, let's say the index that we want to go into after transition will be 2. So that means the 2 is referring to here. So that means our current state is now going to refer to this particular states. And now, if you try the following, that's something I didn't really say over here. So if you try, let's say, let me highlight to you 2 points over here. Point number 1, if you say over here, imagine that if you try a line right after this, if you say current states dot display versus if you say right after this line over here, okay, right after this line, right after you say current states are reassigned, you say current states dot display. So you can see the pink line and the orange lines are exactly the same. However, are they going to give you the same display messages? The answer is no, because according to dynamic binding, the pink one over here is going to call the display version that is defined in the initial. On the other hand, the orange one over here, because the dynamic type for current state has been changed to flight inquiry. So that's why it's going to call the version that's defined in flight inquiry, right? So that's kind of the manipulation you want to know. All right, let me go back to the slides. And let's finish discussing the clients. So now we want to define this execute session. Basically, we want to keep interacting with the user until the current state reaches the final states, especially when the index gets to index 6, which is corresponding to the final state. That's what we want to do. So we're going to just run a loop with the necessary local variables, and then it's very similar to what we just discussed already. So now I have 2 questions for you. Let's say inside the iteration for this particular interaction section, so I want to know why this line over here, whenever we are trying to reassign the current states to some stored objects in the states, is really illustrating polymorphism, meaning that an object might have multiple shapes. And also, why this line over here, when we say current state execute, remember the template design pattern, why it is illustrating dynamic binding? So that's my question to you. Think about it, and then I'll just give you one quick hint about how you can think about it. Okay, so this is basically the interaction session code. For thinking about polymorphism, think about what are the possible values that could be in the index. It can be from 1 up to 6. And now, what does it really mean when index is 1? And what does it really mean when index is 6, for example? And then for dynamic binding, you want to think about accordingly, however current state is reassigned. So now, how is it going to affect the execution for execute? So you may want to refer to our discussion previously about the state design pattern, especially when the template design pattern is also in the play. Okay, that's my 2 hints for you. So try to do these exercises. I think it's quite important to summarize the design pattern for the clients, for the client's usage for the design pattern. Okay, let's go back to the slides. So this page here simply just summarizes all the client's fragment of code. So I don't need to repeat them. They have been discussed already. Okay. To end this lecture, I would like to make a concluding remark about discussing the fundamental difference between the non-OO versus the OO solution. The slides has already written up what I want to say, but let me illustrate exactly what the syntactic difference is and also the fundamental difference behind. So for the top-down non-OO solution, so we declare the current state to be of type integer. So this is why whenever we say execute states, we have to pass the current state around between different levels, right? So this is the non-OO solution. You should only go for this design if the OO ability is not really given to you. Let's say you're programming in C. On the other hand, if the programming language you're using does support OO, in that case, you should really go for the object-oriented solution. In that case, you simply declare the current state to be of type states, which is the top class in the hierarchy of the state pattern. In that case, at the runtime, the current state may be dynamically referring to either initial flight inquiry, any of the effective descendants. In that case, when you call execute, it's going to execute this particular pattern over here. However, dynamically, it's going to refer to the correct version of each of the deferred feature that's being effected in any of the classes over here dynamically. Okay, so that's really the essence for the OO solution. If you simply just go back to the slides, that's exactly what's being written up. So I'm not going to read off the slides. So how do you study for this lecture? I would suggest clarify what the motivating problem is for the interactive systems and study design attempt number 1 and number 2, note about their context of usage and also know about their pros and cons, and then study the ultimate solution, really try to see exactly polymorphism and dynamic binding are in the play. In the effects, which will confirm what you learned previously in the inheritance lecture. Specifically see how the template design pattern is really working at the runtime.